Hi folks, this is the second video clip that I'm making on parametrizing an assembly, and the first one that I made actually was very simple. It was a disc inside of a shaft inside of a disc, and I was also planning to do this thing using the copy and special paste, but it's so simple that I decided not to. However, I will do that for the other examples. Now we have a gray object called box here, which is a cube, and then there is a wedge that's cut out. So there are two parts, and the parameters are L, H, W, and this angle beta. Okay, what we like to do is to make sure that the parameters that we create at the assembly level actually show up in our tree like that, and then we go there and change the entire assembly from here. Okay, so let's start with our Catia program. Immediately we save this thing, file, save management, save as. We're going to put this thing on our desktop, new folder. I'll go and call it assembly parameter 2. Okay, and everything is going to go into this folder. Alright, let me remind you how to make sure that all your parameters later on that you show do appear in the screen. For example, tools, this is how you do that. Tools, options, and if you look at infrastructure, product structure, and there's lots of tabs here, you scroll all the way to the end and select the tree customization. What you should have here is parameters relations should be active, so it should say yes. If you don't want something, so you select it and you say deactivate. Notice that it goes away. Okay, but anyway, I don't care about material. I want parameters and relations. Constraints are also not important, but anyway, let me put this thing back on. So this activate, although I don't need it. So any parameters that I create here are going to be showing up in my tree. As a matter of fact, let me create my parameters right now, because they're totally independent of the model at this point. We just want to create them. So we click on f of x and say new parameters, and the first one, let's call it, I think we called it H if I'm not mistaken here. Let me see, big H, yeah, big H, and we give it the value 1. These are all random numbers that I'm picking. And then another one, W, also 1. Another one, the length of remember the length of the block, I'll call it L, and give it the value, I don't know, 3 or 4 or 5, whatever, it doesn't matter. Apply. Okay, apply. And now the next one is the angle. So I have to change this thing to angle type, and you click on it, and I think I called this thing here beta. Okay, so we call this beta, and let's give it a meaningful value, because later on, if we give it a value that's not reasonable and we set it equal to that, the whole structure collapses as far as geometry is concerned. So let's make it, I don't know, 45 degrees. Okay, apply. And these are notice that my parameters do show in the screen, and I have nothing made yet. So let's make the block first. So insert a new part in there, and this is going to be the block. So I'll call it the box block, okay, or a cube. Okay, so properties, I'm going to call this thing where is that? Right here, cube. This is the instance name, and this is the part name, cube. Okay, good. And let's make it. So we double click on the cube. On the convenient plane, for example, on this vertical plane, I will sketch I don't know, a rectangle. Later on, all these sides are going to be equal to W. Now let me see what the size of this thing is, by the way, because remember H and W were assumed to be 1, so later on, okay, that's good. So yeah, fine. Roughly, this is roughly 3.5. All right, so we're going to pad it. Now I'm going to pad it by also 4, something like that. Okay, good. Actually, let me do it in the other direction. Click and reverse it. All right, now I want to make a cutout here. Okay, I want to create a cutout there. Okay, so there are the different ways of doing this problem. On this front face, I will sketch. I don't want you to get the impression this is the only way. There may be better ways. So I'm going to make this cutout. Remember, this is going to be that piece where this angle is going to be beta and this is going to be W, and depth is going to be later H. So let me dimension these things. So this is going to be later on, it's going to be my H, and this angle, actually I think this is W if I'm not mistaken. Let me check for a second. Yeah, that is W. That's fine. We're going to worry about these things later on. Exit. Now I want to create a point here so that then I can create a plane through 3 points, these 3 points, and then cut this to make a wedge. Okay, so there are different ways of doing it. For example, I can make a point right here on a curve. Okay, there's the curve and there's the point. The actual location is not important right now, so we do have a point, all right, right there. So let's create a plane passing through these 3 points. So create a plane, 3 points. Let me see now, where's the 3 points? Right there, through 3 points, through this point and that point and that point. Okay, and we say okay, and we're going to cut this object, split it with that plane. So we're going to split this. Which side do you want to keep? The other side you want to keep. All right, and there we are. Okay, so save everything. Right now we haven't done, keep in mind that we haven't done anything with our parameters yet. Okay, then we're going to make the wedge. So insert, new part, in there, right click, properties, see properties. I'm going to call this thing the wedge, and the wedge. Okay, let's make the wedge. Double click. Now the wedge is going to be something that looks like that. So just to give you a better idea of what I'm doing here, let me not make the wedge right there. So I'm going to create an arbitrary plane here and then construct a wedge on that. So let's create a plane offset from this in the other direction. Let's go further, because I don't want you to mix these two figures up. Okay, on that plane I will sketch. All right, let me flip this. Let me here's what happened. We are drawing on this sketch. Okay, so as a matter of fact, I'm going to hide this block so that it doesn't bother you too much. So I'm going to hide this, okay, and then make that rectangle, not rectangle, what I meant was a triangle. This, there, and there. Okay, let me make these things a little bit smaller, roughly about 1.5 inches. Okay, let's dimension these things. So dimension this eventually is going to be my W, and the angle between these two is going to be our beta. Okay, exit. All right, just to show you what happened here, let me bring our block back so that it's right next to you. You can see it. Right, so now I want to create a point there and make that basically this this wedge. Now there are different ways of doing it. I'm going to do it the way probably you feel comfortable with. So I'm going to pad this. Okay, pad it more. All right. Then on that I'm going to create a point, and again a plane, and cut it out. So let me see. Where's the point on a curve? On a curve. So on this curve, there's my point, and we say okay, and create a plane through 3 points. Is that the one? 3 points through this point and that point and that point. Okay, and then split it. Split with this plane. And which side do you want to keep? You want to keep that side. Yeah. Oh. Let me see. Actually, let me see what I did. That split, that last thing that I did, this is nonsense. So I'm going to delete this. Try it again. So where is that split with this plane? And that's the side that I want to keep. That's correct. Oh, I want to get a wedge. Later on, this is going to fit into that thing. Okay. So there are no assembly constraints right here. The sizes don't match, but that's the whole point. We're going to try to do that right now. Okay, so here's the situation. Let us click on f of x. This is where we go. Click on f of x. This is where we're going to actually put our formulas and things in place. Now let's start with, let me select this wedge, because only the dimensions of the wedges are going to show up. And let's see, this is going to be my W. So add the formula equal to, either you can do it from here or you can do it from the tree, it doesn't matter, or you can just type it. So this is going to be my W. Say okay. This is going to be my beta. Add the formula, there's my beta. Okay, and this distance, let me see now, this was the padded length that, remember, I cut out. But this point, if you look at this point, see this point, if I select this point, there we are. The length from this point to that plane is 1.277. So I want to say add a formula equal to, that's going to be my h. Okay. If I say okay and update, this is the wedge with these dimensions. So let's go and now do exactly the same thing with this block. So f of x, first of all, it is supposed to be a cube, right? So I click on that. This is supposed to be L. This is supposed to be L. The formula, there's my L. This is supposed to be L. The formula, L. I just remembered that something that I forgot. I didn't put a dimension here, which is also supposed to be L. We can do that later. All right, what else do we have here? Angle. Remember that that angle of that sketch? Where's my sketch? The sketch that I initially drew on this face. So let me see now. It was in must have been, no, it's not there. Which one? Oh, this is the wedge. I'm sorry, this is the wedge. I'm not interested in the wedge. Let me see. Yeah, right here. This is beta, right? This thing is beta. The formula equal to beta. Okay. This is my, according to the drawing, this is my W. Let's check that. Yeah, see that? It is W. The formula, W. Where's W? Right there. And this dimension, 1 point something, is the coordinate of that point along this line. So let me see now. This point should be equal to h. Add the formula, h. Everything is going to work, except that the only problem is that I did not have this thing set equal to L, therefore that's not going to be a cube. We can always fix that. Actually, let's go ahead and do that. The first, in the cube, let's go to the cube, okay? The first path that we did is right here in that sketch. I forgot to dimension this thing because eventually this is going to be L also. We're going to do that now. Exit, okay? One more time, f of x. And we are interested in the cube, and this dimension is going to be add a formula equal to L. Now if it says 5 and it doesn't say L, this is not acceptable. The reason is that you are at the cube. You have to go to the product, so cancel that, okay, and cancel that. It's very important that you be at the product level, otherwise it will not take the parameter, it will take the value of the parameter. Double click on this, add a formula, sorry, f of x, you click on that and you select this guy, add a formula. Now you can select L. Before it was just taking the value of L, whatever it happens to be. Okay, and update. They should fit. You can see that they do fit. Now let's put the constraints here. Let me hide the sketch. In fact, all of these planes I'm going to hide. So 1, 2, 3. Where is that control? I'm going to hide these. Any other planes that I created, I'm going to hide. What else do we have? We have wedge, a bunch of things, this and that and that. I'm going to hide. And there was another plane here I'm going to hide. I mean, these points I'm going to hide. And there's another one here. I don't need it. I'm going to hide them. Hide. Okay. Actually, let's make also the color of this thing maybe yellowish so that you can see. Or let me give it opacity. Opaque opacity, right? Properties, graphics, so that we can see what's behind it. There we are. Okay, very good. Now let's put some assembly constraints. So coincidence between this point, actually let's do it like that. Coincidence between this point and that point. Let me do it a different way. So coincidence between this face and that face, and coincidence between perhaps this edge and that edge, and also coincidence between this edge and that edge. Let's update it and see whether it works. Okay, good. Now let us go and change our parameters. Actually, we also hide the constraints. Very good. So let's see. Okay, I want to change the color of this cube. Properties. Let's change it to yellow. Very good. Okay. Let's start with L. L is the size of the cube. So let's make it 7. Update. There. Became large. Let's take H. H is this distance. Let's make it 5. Okay. Update. Whoops. There is a screw up here. So we have to go and fix this guy. I have a feeling that when I created when I set this thing equal to something, it was actually not the point. It must have been some coordinate of that some point. Well, anyway, let's find out. Let's find out the other one. W is this height, so let's make it 3. There. And beta is this angle. Let me make it I don't know, 60 degrees. update. So everything is okay except for this equation. All right, so that's good. Actually, we can find out what happened here. So let's click on this, and we click on that. All right, it's this guy. You see this? It's that fellow that I should have added equal to H. Okay, I don't think I actually ever did this, so let's try it now. Yeah, I never did this, I forgot. So you select this, add a formula equal to H. I never did this piece. Okay, and update. Now it's all right. Everything is good. All right, so let me see where we are. Do we have time to do it right now? I'm going to try to do the second piece, namely using the copy special paste. I'm going to do it on a different video because in case things become longer, then at least we can go ahead and watch this one as a single video. Okay, so we will repeat this problem, except that I will do a copy and special paste. Okay, stop it.